All right. So a wonderful example of how many times should I say something before it sinks in. I know it's 15.2%, but what do I write here? 0.152. You want to get yourself started on the right foot. You put 15.2 in these equations, you're going to get like the probability is 10 million. I don't think that's possible. 10 million% chance. I was like, what does that mean? I don't know. All right. And so what's Q got to be? I kind of give it away, but oh well. Yeah. So 1 minus this must be this. They get together, they got to make 1. Then if you wanted to try the example out, okay, cool. How do I set this guy up? 44. Choose 7 of them. So how many of these? 7. And how many of these? 37. Kick ass. Which is sort of like where the formula makes it look worse than it is. It's just the rest of the people go here. But this is what it looks like algebraically. And what'd you guys get when you threw that in the old calculator?
0.1611.
Kick ass. So we're normally going to round these probabilities to 4 places. Everybody all right so far? You're like, I'm not going to tell you. All right. I'm here, man. Deal with that. So this one, I want nobody. So 44, choose none of them. So how many of these do I want? None. And how many of these do I have to have?
44.
All of them. 44. Kick ass. And then this is where you get the 7 point blah, 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 E negative 4, right? So then how do I write that?
0.0007.
Yeah. So the neat thing about negative, scientific notation with a negative exponent is one less number is how many zeros? So it's negative 4, 3 zeros. Because you got to move it once to get around the 7 in this case, and the rest are going to be zeros. Okay, maybe. What is that the probability of again? That none of them smoke. So if I were setting up an event, and I was gonna let people smoke if they wanted to, would it be okay if I just didn't bring any ashtrays? The probability that I'm not going to need an ashtray is that, isn't it? No? Yes? You guys understand what I'm saying? That's the probability nobody smokes, which is the only time I'm not going to need an ashtray. I don't care how much, as a smoker, you think the world is your ashtray. That is not true. So I should bring at least one ashtray, because it's a very low probability that nobody's going to need one. You guys kind of follow what I'm saying? So this is sort of related to how many left-handed chairs what I put into a classroom. Well, I can figure out what's probably somebody's left-handed. I can talk about the N would be the size of the classroom. I can figure out on average how many left-handed chairs I should put into a room. And I don't know if there's any in here. There's sort of some neutral ones maybe. Do you have one?
No.
I'm sorry. Yeah. So if you're left-handed, apparently gross one's like, hey, screw you. But, oh, sorry. Yes?
Every time, if you take like testing at San Diego State, like they'll be like, oh, it's left-handed people, and they'll like have you sit on the end.
That's
there's
a
like
little...
certain desks.
I see.
Or,
Okay.
like,
Well, at least they have them, right?
Yeah. And
But it sort of feels like, oh, you're left-handed?
Yeah.
Go to the end. All right. Okay, maybe. Okay. And part C is the most commonly used example of this 1 minus thing. But it's always, this would suck, right? To do this directly, because that would be, I'd do 1 or 2 or 3 up to 44. So if you do that on a test and you complain to me that I made the test too long, you did. You made the test too long. I didn't make it long. The opposite of this would just be none. That's the only thing that leaves out. And we already know this. Right? So I do that kind of thing all the time on a quiz or a test, for example. So this is going to be 1 minus 0.0007. This is like the budget 007, 007. And what's that?
0.9993.
kick ass. There's almost 100% chance that somebody's going to smoke, so that's related again to the fact that I want at least one ashtray out. Okay, I like it. Okay. So these are the little tiny beautiful formulas. Thank the gods. I don't need to make tables or any of that shit. This is brand new to us. N times P, so that's going to be 44 times 0.152. What do you guys get for that? So on average, I expect just under 7 people to smoke out of a group of 44 people. And then what's the standard deviation? It's going to be square root of N times P times Q. And what do you guys get for that? 2.381? 2.38 business, that comes out to 2.381, maybe? What should it be, sorry?
It's 3815, so if you want to...
Ooh, let's see. Dissension, I love it. 44 times 0.152 times 0.848. Looks to me like the one number next to 1 is a 4. Now, so I love that. Please don't take this wrong. I'm not coming down on you. This is something that I hear very often from students. Maybe do it over here, Jeff. It's not dominoes. Is 147 closer to 100 or 200? 100, right? I can't make this become a 5, and then that 5 makes this become a 2. No, it's not dominoes. How do you round anything? You only look at the number that is directly next to it.
Well, how many does that? No, I was just confused because I thought we were rounding to 4.
Oh, I see. So, but standard deviation, I said 3. But remember, I think I said at the very beginning of the semester, if you just make everything go out to 4 places, you're covered.
Okay.
But standard deviation's got to be at least 3.
What did it do?
So you're right. 2.3815 if you wanted to go out one more place. I thought you were trying to say that was a 2.
Oh, no.
Okay,
I was,
okay.
correcting myself.
I got you. That's my fault. So you could say this if you want to. I love it. But it's got to be at least 3 places for standard deviation. Okay, gas. And this should feel kind of familiar, but it's a little different. So, somebody remind me. Do you guys remember at all? I think we talked about this. If I have a normal curve, what percentage is within 1 step, 1 standard deviation of the mean? Somebody remember that number? It was 60 something. So it's possible we didn't talk about this. 68% is going to be within 1 standard deviation of the mean. Why does it kind of make sense? Where's most of the data? If it's normally distributed, most of the data is going to be right in the middle. That's where the biggest hump is. Okay? So what it turns out, if I go one more step out, I catch a little more data. So it turns out that within 2 steps, there's 95% of the information. So what is the probability that, for example, if these are heights, Jeff, stop going that way, your camera's this way. If these are heights, here's the average height, and this is 2 steps down from there, 2 steps up from there. What is the probability that somebody is so short they're out here or so tall they're up here? What's the probability somebody's outside of 2 steps? 5%. If I said there's a 5% chance of something happening, is that very likely? Would that be unusual? Yes. So if you saw somebody who was this tall in here, that's like a grown man, that's like Tyrion Lannister, right? Or if you don't watch Game of Thrones, then, I don't know, Ewok, right? Oh, I'm not trying to be mean, but that would be unusual. You don't see that all the time. If you ever been out in the world and you saw a little person, have you ever done that? No? Or you saw, like when I saw Manute Bol in the airport. Anybody know Manute Bol? It's a basketball player who was 7'7". So I saw a group of people, and then I saw Manute Bol's head in the middle of them all. You know, they're like, oh. So you will do a double take, not because we're assholes, but because we're not used to seeing it. That would be unusual. So we officially, for right now, we define Anything that is more than 2 standard deviations away from the average is unusual. It could be evidence that something is different. So, for example, if do you guys remember, do you know this person, Erin Brockovich? There was a movie about, Julia Roberts was Erin Brockovich. This was the woman that discovered that PG&E was tainting water in California. And there were families who were developing cancer and different diseases because they were drinking and bathing in this water. You guys kind of with me? So how did they figure that out? Well, they could do a study and say the occurrence of cancer, the usual occurrence of cancer we expect would be between this and this. And then in these towns, they saw this many, way above 2 standard deviations. That was evidence that something was unusual, that something needed to be looked at. Okay. So another example. I'm just going to example the shit out of you. We're going to do this example later, but if I toss a coin, if I flip a coin, what's the probability you get a head? 0.5. So if I flip a coin, let's say 1,000 times, right? Number one, I'm a little concerned about my life, where I am in my life, where I'm just sitting there flipping a coin 1,000 times, because there's worse things I could be doing. Could somebody figure out for me what the average number of heads I would expect? Yeah, we don't even have to do the formula, do we? It's half 1,000, so it'd be 1,000 times 0.5. I would expect 500. But now I can ask, would it be unusual if I got 507 heads? How's that feel? Would that be weird if I flipped the coin 1,000 times and I got 507 heads? Would that be weird? No, because it's not really that far away from 500, right? But where does weird start? Would it be weird to get, it would definitely be weird to get like 900 heads. You guys agree with me? If I flip the coin 1,000 times and I got 900 heads, is that impossible? No. Is that so unlikely that I think something's weird about that coin? Yes. That is evidence that something unusual is happening. I love you guys. This is actually, I understand. I'm very often to be the only person that's really interested in something because I teach math, but that's got to be sort of interesting. That is how I accumulate evidence to start to piece together, does this drug have an effect? Did it have more people than expected get relief quicker? This kind of leads into a whole bunch of stuff. So what is the standard deviation here? One more zero, Jeff. Boop. What is it going to be? It's going to be roughly 16, 17, 18, I don't know, 16, 15? Yeah, roughly 15 point something, I think. You guys can... 15.8, 1, 0? 1, okay. Yeah, there's 0. So real quick, so let's say about 16, right? Just for the sake of this argument. You with me? So how many heads would I expect? Well, I expect 500 heads, but what would be okay? What's the least number of heads that would still be normal to see officially? I take 2 steps down. So minus 16, so minus 32, 468. So officially, if I got 460 heads, that's possible evidence of something weird. And then if I go 2 steps up, I expect at most 532. So again, if I got 550 heads, that is some evidence. If I got 900 heads, that is strong freaking evidence. If I got 533 heads, that is weak evidence, but it's still evidence that something unusual might have just happened. Can you guys see that? You guys get a feel for that? I mean, we're trying to define better. All right, I flip a coin, I expect so many heads, but when does it start to get weird? Right now, we're going to define it to be 2 steps up and down. That's what we're defining right now to be weird. later. Is this high stakes? If I'm wrong, will something blow up? No. So if I'm in a nuclear power plant and there's an expected operational value something, and you see these little dials with the yellow and the red. So am I going to get off my ass? Am I going to wait for it to be 2 steps away from the normal operation? No, that thing is approaching the yellow. I'm going to go, look, what the shit's going on, right? I don't want to start Godzilla off and shit, right? Poor Bryan Cranston is going there. Who's his wife? No? All right, sorry. Okay, so coming back to this problem. So would it be unusual to find 15? All right, so if I ask that question, you got to first figure out what is usual, and then I can see what's unusual. So in the middle goes the mean. That's kind of familiar, but now I'm going to take 2 steps up and 2 steps down. So what's 2 steps up? I think it's going to be 11.45. And what's 2 steps down? 1.925. Do it again, sorry. 925. Okay. So I always do this for myself. Like that. So would 15 be unusual? Because this is the usual area. This is what I expect something in there to happen. So if I saw 15 people who smoked out of a group of 44, I'd stop and say, where am I? Is this an area where people smoke, or is certain type of people in this area that just happen to smoke more? There's something unusual going on. Possibly. Okay, maybe. All right, so let me leave that right there. I got another handout, but I think I want to do a little bit on the board before I give this bad boy out. You guys, darts. You know what darts are? Yeah. I don't mean lawn darts. I think those were outlawed. Which I remember when I was a little kid, we had lawn darts, and if my mom wasn't watching us constantly, we probably would have had one of them go in somebody's head. But I'm talking about just regular darts with the board on the wall. You guys with me? You go to a bar, you just kind of avoid that area because who knows how inebriated they are. They want to walk out of there with some free acupuncture. So the normal dartboard kind of looks like this a bit. And it should come from the center, but too bad. And these triangles go all the way around. Right, roughly. And there's other stuff to it, but I'm just going to go for this. So if you're playing like a regular game of darts, there's a lot of different ways you can play darts. But what is it you're trying to hit? For the most part, if you're just kind of playing around, you're trying to hit the bullseye. Why are you trying to hit the bullseye? Why is that so special?
So small. So small.
It's so small, which means if I'm just randomly, so if I just stand on my back to it and just start throwing darts back, and I only count the ones that hit the board. So if I get one there, I don't count it. If I get one in my little brother's head, I take it out, move them over, right? I'm only going to count the ones that hit the board. Am I just randomly throwing it? The probability it would land in this triangle. Why is it bigger than the probability it would land there?
It's a bigger area.
Bigger area, kick ass. All right, so if I can visualize a probability distribution, the areas within that distribution relate to the probability I would get in that area. So if I'm just throwing darts over my shoulder, then they would be more likely to show up here than they would be to show up there. Because that's a smaller area than that is. You guys with me so far? So, for example, there's something called a uniform. Are you the bad one? Or are you just dying? Poor little dude. Come here, blue. Uniform probability distribution. So we had a binomial. That's the one we talked about last time. Tell me this real quick. Binomial. Was it discrete or continuous data? So what's a binomial situation? You have so many people, and you want to know the probability that this many of them have the flu or something, right? So is that discrete or continuous? And you're all like, that was the last test. I don't have to worry about it. Yes, you do. Of course you do. You're still in this class. Discrete or continuous? The number of people or number of things? Discrete, because I can count them. They skip values. I can't have 4.89 people had a flu. Right? That would be Sept flu. You are a person. I don't care how sick you are. I'm about 0.7 of a person today. It still kind of makes sense, but we're not really. Okay, maybe. So this is going to be a continuous distribution. So chapter 5, we're starting to get into continuous distributions. So for example, here, uniform, get back in. Anybody ever ride the bus? And it's okay if you did. I did. Anybody ever ride the bus? Okay. You go to a bus stop, and it's supposed to be there. So let's say we're in Germany. Have you guys ever been to Germany? Germany, the trains and the buses it's almost like annoyingly on time in a weird way. It's like, oh my God, you're so on time. And then you go to Italy and it's like, oh, it's only an hour late. Who gives a shit? So it's really disturbing. But so let's say we're in Germany and the bus comes every 15 minutes. So what's the best thing that could happen in that situation? You come to the bus stop and what's the best thing? It's there, and it hasn't left yet, and the door's still open, you can get on. You with me? So that would mean you waited how long to get on the bus? No time. What's the worst thing that can happen? You get to the bus stop and door's closed and it starts to pull away, and you're like, shit. And now how long are you going to have to wait? 15. But when you walk to the bus stop, there's no waiting time that's more likely than any other. You guys kind of with me? No? Yes? Maybe? You get to the bus stop and you don't see a bus. You could wait anywhere from like a minute to 14 minutes or so, right? You guys semi with me a little bit? Okay, so this is what it means by, what's the word uniform mean? When I say uniform, obviously what comes to mind? Same. When I say uniform, come on, what comes to mind? Uniform. What do you see in your head? I see my bed, Jeff. This is my happy place. When I say uniform, what comes to mind?
Private school kids.
High school kids. Why? What kind of high school?
Private school.
Private school. Because they have to wear the same uniform, or a cop, or whatever. So uniform means the same across the board, right? I want to distribute the money uniformly means everybody gets the same amount. So a uniform probability distribution means all the probabilities are the same. So if I drew like the histogram, it would be every bar would be the same height. And I said it came every 15 minutes, right? So it's going to look like this. All right. So what we're doing right now is something we've not really done before necessarily. Whenever I draw the normal curve, I am sort of doing this, but I'm doing a visualization of a probability distribution. So whenever I draw the normal curve, that is what I'm doing. What should the area of the whole block be if it wants to be a valid probability distribution? What do we say area is related to? The dartboard, the probability, right? The area, how big the area is related to the probability I get there. So what should the area of the whole block be if it wants to be a valid probability distribution? What should all the probabilities add to be? All the probabilities in a situation should add to be what? Oh my God. So if you have a relative frequency distribution, which is really probabilities, or if you have an x, p of x, what do you check about the p of x's? They all have to add to be 1. There it is. So what do I have to do to make this area 1? How tall does this have to be? If this is 1 tall, what's the area? 15. Try again. How tall does it have to be so the area is 1? 1 over 15. There it is, right? The reciprocal. Hey, what do you multiply a number by to make it 1? It's reciprocal. Do you remember that? How do you solve this equation? Multiply by the 4 over 3. Why? Because that makes this 1. Blah, blah, blah. Who cares? So we know when we multiply by the reciprocal, we get 1. All right, so let me really come back. If I draw a representation of a probability distribution and I make the total area 1, then I can figure out any probability question by figuring out the area related to that question. So for example, this height has got to be 1/15 in order for this to be a valid probability distribution, because now the total area is 1. You guys with me? How do you figure out area? Length times, in this case, height. You get 1. Yay! Okay. So let me ask you a question here. Let me take this away. What's the probability that I have to wait between 3 minutes and 8 minutes? Can you draw it in here? Yes, you can. So here's 3. Here's 8. The answer to that probability question is going to be the area of that block. That's beautiful. It's exactly like the dartboard thing. What's probably I get in that region, it's equal to the area of that, just like the dartboard was. How do I figure out the area of this? Well, how wide is it? 5. And how tall is it? 1/15. So what's this probability? It's going to be 5 times. Okay. So several things happened, and a couple of them we've actually done before, but we weren't so explicit about it. But if I draw a probability distribution, whatever the shape is, and I make the whole area 1, then any probability question somebody asks me becomes just finding the area related to that question. Same thing with a dartboard. What's probably I get there? Well, it's the area of that little piece. If the whole area is 1, and this area is 0.01, then what's the probability I get a dart there? 1 out of 1, or 1% chance. So that's that. What about, all right, you guys take a second to figure out this. Yeah, Jeff, gross. Yeah, that's yummy. Okay.
Is that 2.7?
That is a 2.7. Because I'm a math teacher or me. Now, I'm just going to reuse this. It doesn't really matter if it's to scale. The height is going to always be 1/15. For any question related to this, it's going to be 1 over 15. So the thing that I don't know is the width. Well, how wide is this? 9.2. This is going to be 1/15 times 9.2. And then you can just do that in the old calculator. It's like 0.16. Is that right? What is it? I'm sorry. 24? Oh, 20 point. So 0.2024? Is that what you're saying? Whoa, I'm getting all kinds of stuff. All right, let's try some. So, what did I say? I was way off. 9.2 divided by 15, 0.6133. Let's try that again, right? It's 9.2 divided by 15. Is that cool? You guys with me? Okay, all right. So let me ask you a really exceptionally weird question, which you could argue is every question I ask. But let's see. What is the probability that I have to wait exactly 8 minutes? So let me remind you about a couple things. What are we realizing here? If I have a visualization of the probability distribution, probability is equal to the area. X equals 8 is what kind of thing? Here's 8. X equals 8 would be this, right? You guys with me? That's x equals 8. What's the area of a line? You could do it. I love you guys. You're all like, why am I here? Not on the earth, but in this class. What's the area of a line? How wide is a line? 0. So it's the area of a line. Area is length times width. If it's 0 wide, the area is 0. Let's investigate why the shit that is. Are you guys all freaked out about that? This is exactly related to when we were talking about continuous and discrete. The likelihood that I find a person who's exactly 6 foot tall is basically 0. Because I'll bet you anything they're not exactly 6 foot tall. You guys with me? If I measure them more and more and more precisely, I'm not going to get 6.0000000. No. I'm going to get 6.00234 maybe. So think about this real quick. If I had 10 things to choose from, what's probably going to get one of them? 1 out of 10. What if I had 100 things to choose from? Let's probably get one of them. 100. It goes from 10% to 1%. Of course, the more things I have to choose from, sure. What's probably get one of them? 1 over bigger. How many numbers are between 0